Welcome back to Algebra 1 with Miss Betsy. Today we are going to be discussing how we factor perfect square trinomials, and we'll see that this is a particular form of a trinomial that when you recognize the pattern that it always follows, it makes it very, very easy and straightforward to factor this. Before we start though, I've got a lame joke for you, submitted by some very young child I'm sure out there on the internet. And he says, what did one math book say to the other math book? Boy, do I have problems. So, if you're using my text, which is Algebra 1 for Christian Schools, it's published by Bob Jones University Press, and I am using the second edition. You'll see that we're working today in section 9.3, and we're on page 371. We're factoring perfect square trinomials. It's a pattern recognition thing, so let's see what we can figure out along with this. I just mentioned pattern recognition. Something that you've just recently been learning how to do is factor the difference of two squares. Do you know what the difference of two squares is? Let me grab my eraser. Does the difference of two squares mean something that looks like that? Well, no, but that's an abbreviation. If you want to do some quick notes, you can say, oh, I recognize that I'm subtracting two squares. So if we had x squared minus y squared, you recognize that the first term is x squared. The second term is a factor of y used twice, which means that it's also squared. The difference of two squares factors into two binomials where you have opposite signs in each binomial factor. The first term is the square root of the terms of the binomial. So you have the sum of their square roots multiplied by the difference of their square roots. And as long as you recognize the pattern of the difference of two squares, it's very easy to factor a binomial. 16x squared is a perfect square. Let me write over here that the square root of 16x squared is 4x, because 4x times 4x is equal to 16 squared, 16x squared. 144z to the fourth is also a perfect square, because if we take the square root of that, that's 12z squared, and now you see why I slash my z's and do nothing to my 2's, otherwise it might be difficult to identify those. And if you went ahead and said 12z squared times 12z squared, you would end up back with 144z to the fourth. Okay, so we recognize that this right here, as I'm reviewing the difference of two squares before we do perfect square trinomials, we notice that if we take the square root of the first term, we have 4x. We take the square root of the second term, we have 12z squared. And we remember our pattern that says if you have the difference of two squares, you have two binomial factors. The first factor is the sum of the square roots, 4x plus 12z to the fourth. And the second binomial factor is the difference of those two square roots. So the difference of two perfect squares, 16x squared minus 144z to the fourth, factors into 4x plus 12z squared times the quantity 4x minus 12z squared. You wouldn't begin to know how to come up with this answer here if you didn't know the pattern. If you didn't know that when you factored the difference of two squares, you have the sum of the square roots of the term. You have the difference of the square roots of the two terms. Now, when you're trying to factor a perfect square trinomial, you have something similar, but it's not absolutely necessary. You can always brute force what the factorization is for a perfect square trinomial, but there is a pattern that you can recognize. So let's look at these, as we develop this, let's look at x plus y quantity squared. Now if we were going to go ahead and just FOIL this, we'd remember that our exponent 2 means that we are going to use the expression x plus y as a factor 2 times. And if we apply FOIL, our method of FOIL, we have the first terms multiplied together, x squared, plus the product of the outer terms, plus the product of the inner terms, plus the product of the last terms, which gives us, not an equal sign there, x squared plus 2xy plus y squared for the product of x plus y quantity squared. So what do we have then if we have y plus 4 squared? Y plus 4 squared. If you're just simply using the fact that our exponent here indicates we're using the same binomial as a factor twice, you would then go ahead and use FOIL, and you would end up with y squared plus 8y plus 16. Okay, let's look at another one. If we have x plus 3 squared, that's going to end up being x squared plus 6x plus 9. And one final example here, x minus 1 quantity squared. When we use this as the product of two binomials and we use our FOIL method, we end up with x squared minus 2x plus 1. Now let's look at these four answers here, these four products here, and see what they have in common. Okay? Well, the product of two binomials, it's the same. Every single one of these products is a trinomial, isn't it? They all have 3 terms to them. Okay? First thing, it's a trinomial. What's the second thing that we're going to notice? Well, if you look at the first and the last terms, they're all perfect squares. X squared, y squared, and 16. 16 is 4 squared, x squared. 9 is 3 squared, and of course 1 is a perfect square as well. So they're all 4 of these products here are trinomials. All 4 of them, their first and their last terms are perfect squares. Now, let me read this directly from your book so that you'll see that they're using the same words that I would use. The middle term, I want you to look at every middle term that's here. What's our middle term? We have 2x, we have 8y, we have positive 6x, and we have a negative 2x. And let's look at those and see what the relationship is. And this tells us the middle term is twice the product of the square roots of the first and second terms, or the square roots of the first and last terms in our binomial. Okay, so let's take this algebra language apart and see what it's saying. This middle term right here, twice the product, 2 times the product of 2 different numbers. What is it? It's twice the product of, 2 times the product of the square root of the first term times the square root of the second term. Okay? Square root of the first term here. Square root of y squared is y. The square root of 16 is 4. We're going to do twice the product of their square roots. The square root of 16 is 4 times the square root of y squared is y. So we have 4y, we double it, and we get 8y. We're going to take the square root of the first and third term. Square root of x squared is x. Square root of y is y. We have the product of the square root of the first and second terms. And we double it. xy times 2 is 2xy. Let's look at this one right here. What's the square root of x squared? It's x. The square root of 9 is 3. Their product then is 3x. What do you get when you double 3x? We're not squaring it, but when you double 3x, or you say 2 times 3x, you get 6x. Square root of the first term is x. Square root of the last term is 1. 1x doubled, or multiplied by 2, is 2x. And look at the relationship between the signs. We've got a positive sign here, positive, 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 negative sign, the negative sign. So you have a relationship. The sign of the binomial is the same as the sign of that center term of your product, or the center term of your trinomial. Okay, so let's review the 4 things that we see. The product of a binomial squared is a trinomial. Okay, 4 trinomials. The first and the last terms of that trinomial product will always be a perfect square. Your second term of that trinomial product, here, all of this math vocabulary here, vocabulary in my speech, this second term here is always twice the product of the square root of the first term and the square root of the third term of that trinomial answer. And that's how you recognize a perfect square trinomial. So let's go ahead and look at some of these and see what happens. We're going to be on the next page, which is page 372. I'm going to go right here and go through these examples. The question here says, factor x squared plus 10x plus 25. So we're going to look at this, and first we want to think, well, something I hadn't mentioned is when you're back in section 9.1, we're talking about factoring common monomials. You're always looking, the very first step when you're factoring something is first see if you have a common monomial factor. So this is going to be covered by me, hidden by me, but this is the first thing that you want to look for, a common monomial factor. When you are factoring an expression, is there a monomial factor that you have in common? Like, is there, this had been 5x squared plus 10x plus 50, there would have been a factor of 5 in common that you could factor out, as we discussed in 9.1. However, there are no common factors here, 1, 10, and 25, no factor in common. So now we want to determine, we want to recognize, is this a perfect square trinomial? Well, no common factor. Let's look at the first term and the last term. Are they perfect squares? Yes. 1 times 1, or x times x is x squared. 5 times 5 is 25, so we do have 2 perfect squares here. Now, if it's going to be a perfect square trinomial, though, there's something special that goes on about this middle term. For it to be a perfect square trinomial, this middle term must be twice the product of the square root of the first term and the square root of the second term. So let's go ahead and see if that's the case. What is the square root of the first term? Well, the square root of x squared is x. What is the square root of the third term? The square root of 25 is 5. What is twice the product? It's going to be 2 times x times 5, which is equal to 10x. So twice the product of the square roots of the first and third terms of this trinomial expression is equal to our center term, the middle term of our trinomial, 10x and 10x. So this is a perfect square trinomial. A perfect square trinomial has a single binomial factor that is squared. The first term of that binomial factor is the square root of the first term. The second term of that binomial factor is the square root of the third term. The sign in the middle of those two terms is the same as the sign in the trinomial which you are factoring, which is positive. So when we were then given the instructions that said factor the trinomial x squared plus 10x plus 25, our solution is x plus 5 quantity squared. And they do not want you saying x plus 5 times x plus 5. Because that would be like saying 2 times 2 is your solution instead of saying 4. They want you using the exponential expressions for multiple use of factors. But over here to say x plus 5 times x plus 5, I'm going to use that for just a moment and show you that, yeah, it's true. By foiling, x times x is x squared. The outside terms plus 5x. The inside terms plus 5x. And then finally the product of our outer terms is 25. Of our last terms product, pardon me, the last terms multiplied together gives us 25. Our outer and inner terms add together, combine to give us a 10x. And you see that when we use FOIL to multiply x plus 5 squared, we do end up with x squared plus 10x plus 25, which is the problem we began with. So this is the correct factorization. Okay, let's go ahead and do example 2. X squared plus 12x plus 9. X squared plus 12x plus 9. The first thing we want to check, is there a common monomial factor? Do we have any greatest common factor that we need to pull out first? No. Okay, well let's look at the first term. The first term is a perfect square. The second term is a perfect square. In order for this to be a perfect square trinomial, there's a special thing that we have to figure out about this second term. What's the square root of the first term? The square root of x squared is x. The square root of the third term, the square root of 9, is 3. In order for this to be a perfect square trinomial, this second term here has to be twice the product of the square roots of the first term and the third term. 2 times x times 3. What did I do wrong here? Yeah. 2 times x times 3 gives me 6x. I must have copied my problem wrong. Okay, I did copy my problem wrong. Let me go back and rather than redo this video because of how long I'm through here, I'm going to say, okay, I ended up with 6x. And this is why I said, hey, I must have copied the problem wrong, because what do we have for a perfect square trinomial? This center term here has to be twice the product of the square root of the first term, which is x, that's not a 4, and the square root of the third term, which is a 3. So yeah, that's a perfect square. This is a perfect square, but when I do twice the product, they don't match, do they? No. So this expression here is not a perfect square trinomial. So I'm going to leave this information up on the board, and I'm going to show you what the problem should have been, and you'll see the difference that we have. Doesn't take long to go through these markers. This one is not a perfect square trinomial. And it's important that you notice that, yes, the first term is a perfect square. Yes, the third term is a perfect square. However, the final condition that you have that identifies a perfect square trinomial is that twice the product of the square roots of the first and third terms has to equal that center term. So when it doesn't do that, it means no, this is not a perfect square trinomial. However, what the problem actually said was factor 4x squared plus 12x plus 9. Now, when we take the square root of the first term, the square root of 4x squared is 2x. 2x times 2x gives us 4x squared. Again, the square root of 9 is equal to 3. Now, what happens when we take twice the product of the square roots of the first term and the square root of the third term? Look here, we get 2 times 2 is 4, times 3 is 12x. And we now have 12x and 12x, so this is a perfect square trinomial. Is a perfect square trinomial. And what does our rule tell us for factoring a perfect square trinomial? It tells us that we have a binomial factor that is used twice. It's squared. The first term is the square root of this first term. Square root of 4x squared is 2x. The second term is the square root. We have 3. And the sign that separates these two square roots is the same as the center term in your trinomial. So 2x plus 3, quantity squared, is the factored form of this trinomial 4x squared plus 12x plus 9. Okay? So let's go ahead and do another example. Wonder what in the world I did with, there's that eraser, that cap. You see the importance of going back and making sure that you are copying your problem correctly, because when you don't copy your problem correctly, you end up with solving a different problem. Now I can go through and solve a different problem and know that I've done it right or tell you what I've done wrong. It's not quite so easy for you, and it certainly doesn't, when you make up your own problem and solve it, even if you happen to do it correctly, Mom can't check it in all likelihood. You wouldn't, because she's got your book right there and she's going back with her solution set. You're going through your solution set. So make sure you copy your problem correctly. We have x squared y squared minus 8 xyz plus 16z squared. I'm thinking that this is a good one to have the book right here, because I'm going to get lost in those letters. Factor x squared y squared minus 8xyz plus 16z squared. We first off have to identify, is this actually a perfect square trinomial? And if so, how do we factor? How do I identify if this is a perfect square trinomial? The first term has to be a perfect square. The square root of x squared y squared is equal to xy. The third term has to be a perfect square as well. And the square root of 16z squared is 4z. 4z, xy. Now what's the third condition that we have? Twice the product of these squares, so the product of not x, but the product of xy and 4z, when it is doubled, has to equal this center term here. 2 times 4 is 8, x times y times z, x, y, z. Do these match? 8xyz, 8xyz, yes they do. So what are we going to do with this sign? How are we going to factor this? First, we know that when you factor a perfect square trinomial, you have a binomial that is used as a factor twice. The first term is the square root of the first term of your trinomial. The third term is the second term in this factor is the square root of the third term. What sign do I use here? Is it going to be positive or negative? It's going to be the same as the sign in your trinomial. So the factored form, then, of the trinomial x squared y squared minus 8xyz plus 16z squared is quantity xy minus 4z squared. I think you're seeing that there's just no way that you can look at this and fudge an answer. You have got to memorize patterns. You have to understand the relationship between these factors. Once you understand the pattern, understand how you arrive at it, there's no difficulty factoring these. But if you don't learn the methodology, you will not be able to solve these problems. And that would be sad. It would make me cry. So let me pick one final example here. This one says, let's factor 3x squared minus 72 xy plus 432 y squared. Now you look at that, and what might you think at first? You might go, can't do it. Looks horrible. How in the world am I supposed to find the square root of 432? And by the way, I know that's not a perfect square anyway, but I don't know what to do. Your kicker right here has this 3x squared in the front. Did you notice that every example that we have factored so far, the leading term, the first term in the trinomial, has always had a coefficient of 1. What's the very first thing that we do when we are factoring an expression? We want to see if there's a common monomial factor. Sure enough, there is. if we look at there are no variables in common, are there? No variables. But do you remember your divisibility rule for 3? If the sum of the digits can be divided by 3, the entire number itself can be divided by 3. 7 plus 2 is 9, which of course you can divide by 3. 4 plus 3 is 7, plus 2 is 9. Again, you can divide 432 by 3. Typically, when you've got larger numbers here, you're going to, well, I shouldn't say typically. It is not uncommon when you have a number in here that is greater than 1, if the coefficient of the first term of your trinomial is greater than 1. It is not uncommon for there to be a GCF that you're looking to factor out first. So, we're going to first take out our common monomial factor. What do we have left? 3 times x squared gives us 3 squared. Minus 3 times 24 xy, because 3 times a negative 24 is a negative 72. I'm not going to go ahead and reteach this factoring. Plus 144 y squared. Now, you should be recognizing that we do have a perfect square trinomial. Our first term is a perfect square, and its square root is x. Our third term, you need to have immediately recognized as being a perfect square because 144 is equal to 12 squared. So the square root of our third term is going to be 12y. For this to be a perfect square trinomial, twice the product of these squares has to be equal to the second term of our original trinomial. 2 times 12 is 24 x times y. And yes, they match. 24xy, 24xy. So we do have a perfect square trinomial that we're going to factor using our pattern. However, I want you to notice, do not fail to pick up on this. You have an extra factor that's out here. So when you're writing this final factored form, you're going to have 3 times the factorization of this. This is a perfect square trinomial. We have the square root of the first term. We have the square root of this last term, 12y. And we're going to use the sign in this binomial, the same sign that you have in your original problem. So your solution to this, to the factorization of this large trinomial here, this is the solution, 3 times the quantity x minus 12y. And I want to take a second here and go ahead and multiply this out so that you see that, yeah, this is really true. Three times x minus 12y quantity squared. I'm going to go ahead and use this, write this as the product of 2 binomial factors so I can FOIL. So I'm going to have 3 times this entire inside product. X times x is x squared. First, outside, x times the negative 12y, negative 12y. Our inner product, we have an x times negative 12y is negative 12xy. Everyone see that? Our inner product, negative 12y times x, is negative 12xy. Make sure that you're putting those variables in alphabetical order. Now, the product of our last terms, negative 12 times negative 12, is positive 144 y squared. Now we're going to collect like terms within our brackets. 3 times x squared minus 24xy plus 144y squared. And yes, you could have changed this to parentheses if you wanted to. Now we're going to distribute our 3. 3 times x squared, 3x squared. 3 times a negative 24, negative 72 xy. 3 times 144. If you needed to sketch that out to the side, carry 1. 3 times 144 is 432, and it's positive, plus 432 y squared, which does give us back our original problem that we were asked to factor. We were asked to factor 3x squared minus 72xy plus 432y squared. And we ended up with this answer right here is the factored form. And yes, this is true, and it looks really strange perhaps to you. But what I just illustrated to you, what I verified for you, is that this expression here is the factored form of this trinomial. And what makes it different is that we have a greatest common monomial factor that we use first. It will be the easiest thing in the world as you're beginning to learn how to factor polynomials, that you'll recognize that you have the greatest common factor here. You'll pull it out, but then in your final answer, you'll forget to include it. Make sure that you don't drop that greatest common monomial factor. Go ahead and play around with these, see how you do. If you need help, shoot me a text. I'll see you next time.